Okay, hello y'all. This just feels so weird not seeing y'all's faces, so we're gonna see how this goes and make the most of it. But I hope you're all doing well and keeping yourself busy and safe and clean and being mindful of social distancing and all that. So before I start this off, I just want to say that I don't have an update on AP testing yet. I think we will get one in a few days, and I think they said March 20th, and I will let y'all know as soon as I know information, but they are going to make sure that y'all have access to take it. So if you have any questions or concerns, I just want to make sure that you're staying busy and staying proactive physically and mentally, and staying healthy. So if there's anything more I can do to help you, please let me know, because I'm still your teacher and wanting to help you learn. So we're just going to jump right into chapter 7. This is our last chapter. We should be able to finish it in these next 2 weeks. And it feels weird recording because I can't go back and fix anything, but so y'all just pray for me that I won't make too many mistakes. What this chapter is over is area and volume. You might have seen some questions on your mock test about that. And I'm going to break this up into different videos today for what the lesson is. I'm going to do 3 examples in this first video, and then there's going to be 2 more challenging ones in the second video if you like to watch that. So I'm going to try to go really slow because I know no one can ask questions. Now feel free to post questions after you watch, but I'm going to go really slow. So if you feel like you understand what's going on and you can speed it up, or if you feel like you need to pause it and slow down and process, that's kind of, I think, going to be the benefit of these online videos, is you can go at your own pace. But I am going to try to go probably slower than normal because I don't want anyone to get confused. So area between 2 curves, I meant to delete this area by itself. You don't really need that. So what we're talking about first is, let's say you have this xy axis, and we'll make f of x some function up here, and we'll make g of x some function below it. And if your question asks you to find the area between the 2 curves from, let's say, we'll make this a and this b, how do we know what that area in between them is? So if you think about it, we know the area underneath f, this total area going all the way to the x-axis, would equal the integral from a to b of f of x, right? We know when you take a definite integral, it's the area under the curve. And then if we take the area underneath, I forgot to label this g of x. If you take the area underneath g of x, it's the same thing. So then if we have blue as this total area and red is this area here, and we just want to know what is this piece, then what could we do? If you think about it for a second, if you want to pause it ever and think about it before I say the answer, is we would subtract them, right? If we took the blue and we subtracted the red, then we'd be left with this black area in between our curves, which is what the question would ask for. So that would leave you with the black area in between them is f of x minus g of x inside your integral. So hopefully that kind of just makes intuitive sense. Same thing if, let's say, you have, this is your y-axis and your x-axis in the middle. We'll say this is still a, b, and now let's say f of x is in the positive above the x-axis. G of x is negative. They don't have to be straight lines either. Would it work the same way? Would you still end up, if we want to find the area between the curves from a to b, which would be this total area, would you still subtract them? So again, if you want to pause it and kind of think about, should you subtract and set it up the same way? And then we're going to look at it. So again, if we break this down, the integral from a to b of just f of x is it always goes back to just the x-axis, right? the area between a curve and the x-axis is the definite integral. Okay, so then we know g of x is down here. So if we integrate from a to b of g of x, that would be this area beneath the x-axis. And what do we know about that area? If it's beneath the x-axis, then that definite integral should be a negative value, right? So what we're going to say is that this original area, we know that's positive, so I'm just going to call it a, some value. And we'll say that this, we know it's negative, and I'll just say it's negative b, just to show you that this is a positive area and that's a negative area. So if we think about this, if we want to find the total area, if we know that it's going to be this area plus this area would equal the total area, but this area is negative, so if you set it up, if you take the f of x area, and to get the total black area, you would think you would want to add it, right? So then you would say plus that negative b area, which we know when you add a negative, that's just subtraction. So it's really, you're still going to take the original integral and subtract the bottom integral. It will take care of the fact that that bottom area is negative. So the goal of setting all this up is just for you to see that the formula to find the area between two curves is always going to stay the same. You're going to take the integral of the top curve and subtract the integral of this bottom curve. So let's go ahead and write that down, and then we'll talk about what if it switches. And we're actually going to put two things in here. We're only going to talk about one in this video. We'll talk about the other one on the next video. So how do you find the area between two curves? I'm going to say if it's vertical, which doesn't make sense yet, but it will after Friday's video, is you take the area will equal the integral, and instead of putting a and b, we're going to put x1 and x2. Again, that's not going to really matter yet, but it will in the future. And you always take the top curve and then you subtract bottom curve inside the same integral. You could break it up into different integrals if you need to, and then you always close it. It's in terms of x dx. Okay, so that's always the setup. You don't have to worry about is it negative or positive. You always just take the boundaries and the top curve minus bottom curve. So then let's come back up here and talk about one more scenario. I'm going to leave this blank for the next video. I'm going to fill that in. So if we have another scenario, and let's say f of x is increasing and then g of x is decreasing, so they cross, and let's say it asks for the area in between f of x and g of x from a to b, and a is over here and b is over here. So if we want to use this setup, we need to know the top curve minus the bottom curve, but if you notice, it switches, right? When you're over here, g of x is on top. When you're over here, f of x is on top. So if you're going to have to break up your integral, if the top and bottom switch, you're going to have to set up two different integrals. So you got to find that point of intersection, and just for the setup, we'll call it C. And so we're going to find this area from A to C and use g of x as the top curve. And then we'll find the integral from C to B and use f of x as the top curve. So you would set it up. My first area is going from A to C, and my top curve is g of x minus my bottom curve is f of x dx. And then you would add the second area, right, because we want the total area. And this integral's starting at C and ending at B, but now f of x is the top curve minus g of x is the bottom curve dx. Okay, so you have to be careful when you graph. If it asks the area from A to B, you have to know, is the top always the same function, or is it going to switch? Because if it's going to switch, you got to set up more than one integral. So let's do an actual example. I hope y'all aren't like hearing me breathe. I feel out of breath. It feels weird. Okay, so it says find the area of the region bounded by the graphs of y equals x squared plus 2, y equals negative x, 0, x equals 0, and x equals 1. So if it ever gives you these numbers, those are just like your boundaries, and it helps to draw pictures on these, okay? So we're going to be drawing a lot of graphs in this chapter. So I'm going to sketch an xy axis. And let's see, the first function they gave you is x squared plus 2. So you should know what x squared plus 2 looks like, right? A quadratic shifted up 2. So you don't have to be super precise when you draw your graphs, but you do have to be aware of intercepts, whether that's x, y intercepts or intercepts of your graph, because it could change the problem if you don't graph it correctly. But we're just going to sketch a quadratic shifted up 2. Oh, I meant to do that in red. Let's see if I can trace black. Okay, that's this function. Now we got to shift y equals negative x. So what does y equals negative x look like? Alright, it's a linear line with a negative slope. It goes through the origin, and we know it goes up 1, 1, 2, 2, and so on and so forth. We don't have to really worry about where it's going to intersect, because we're going to be over here on the positive side anyways, but just for future reference, when I'm sketching this, I do want to know where they're going to intersect. So if we think about that, when are these going to intersect? If I'm going over 1, up 1, over 1, up 1, it'd be like right up there. And we'll do math later on, another example where it actually matters to know the intersection. So something like that. And it might help if you label your functions. Okay, so then x equals 0 and x equals 1. So we know x equals 0 is right here. So it's like a vertical line. Maybe I can even do a different color. X equals 0 is a vertical line right here. And x equals 1 is, and just say that's over 1. And that's another vertical line. So we have, it's saying what is the region bounded by. So you created a shape. Where is that shape? Between here and here. And here's your top curve. Here's the bottom curve. So we're talking about this area right here. So we want to know that area. So we're going to use this setup. Right? So the area is going to equal the integral. What's the left boundary to the right boundary? So our shape goes all the way over to x equals 0. And it goes up to the right to x equals 1. And then you're going to set up top curve minus bottom curve. So our top curve is our quadratic, x squared plus 2. I would always put your function in parentheses. It's not always necessary. But when we do this minus, it might be necessary for the second curve. So just be careful. And I just realized I wrote this wrong. It's y equals negative x. So then we're going to subtract this bottom curve, which is negative x dx. Top minus bottom. Okay, so then we're just going to clean this up and integrate like you know how to do. So we have, do not try to integrate right away. Always see if you can clean it up first. So that's a 0. It doesn't really look like it. We have x squared plus 2, and then minus negative x is plus x dx. Right? Okay, so you can't combine anything. Do not try to factor inside an integral, right? Because then it would make it more difficult. Now we just integrate each term. So what's the integral of x squared? Let's see if y'all remember. This would be a great place to pause the video and try to do this math yourself. Take the antiderivative f of b minus f of a, and then see if we get the same answer. So to get the antiderivative, we're going to add 1. And then divide the coefficient by that, so that would be 1/3 x cubed plus integral of 2 would just be 2x. Integral of x, the exponent's 1, add 1, you get 2, divide the coefficient, that'd be 1/2 x squared. And then that's what you're going to plug your boundaries 0 and 1. Okay, so then, sorry, I was just making sure. Now we're going to do f of b minus f of a. So our b is 1, so you're going to do 1/3 times 1 cubed plus 2 times 1 plus 1/2 1 squared minus, always put your minus in parentheses, your f of a, 1/3 times 0 cubed plus 2 times 0 plus 1/2 times 0 squared. Okay, so if we clean this up, it cleans up nicely, right? Because all these are being multiplied by 0, so this whole thing just equals 0. So we really just need this first term, or I guess not first term, but f of b. So let's clean this up. That would just be 1/3 plus 2 plus 1/2. Okay, so now we gotta add these. So we need a common denominator. So I'm going to put my 2 over 1, so they're all fractions, and my common denominator is going to be 6, right? So I'm going to multiply this one by 2, and it's going to become 2/6. I'm going to multiply this one by 6, and it's going to become, I don't know what I'm doing with my colors, 12/6. And then I'm going to multiply this one by 3. And it's going to become 3/6. Oh man. So now you just add the numerators, and what is that? 17/6. And that is the area of this black shaded region. Okay, I think I'm going to actually stop this first video here. I'm just looking at the time, and I would hate to have done all this and something go wrong, because this is my first video I'm recording. There will definitely be more posted though, but that is the first lesson, so if you feel like you get the idea, the rest of the videos will just be more examples.